This video will show how to use a little understood feature in Solidworks called a projected curve. This command allows us to take two-dimensional sketches and combine them into a three-dimensional curve. For example, this is our Project 3 flow form homework. And here we have an outer edge to this loft, which appears in this shape when we view it from the front plane. When we look at it from the top plane, it has a very different shape, but it's still the same edge. If we look at this in more of an isometric view, we see that this is curving downward, then back upward again as it goes to the tail. So what it's doing is it's taking this information seen from this direction, going downward, then back upward again, and it's also taking this information where it's curving outward, resulting in something that's curving outward and also downward and then upward again at the same time. Quite often when we're creating things in SolidWorks, we know what we want them to look like from one view and we know what they look like from another view. We need to somehow combine those together to get this final resulting three-dimensional curve. If we were to try to draw these directly in a 3D sketch, we would probably have a lot of trouble getting the exact result we want, because for one thing, SolidWorks of course uses a 2D screen. We're already familiar with drawing things in 2D, so it's actually easier for us to draw two 2D sketches rather than a single 3D sketch. I'm going to roll this back and show exactly the situation we have. On our front plane view, we have the shape of our flow form, which includes a top guide, bottom guide, and that outer edge. And then on the top view layout, we just simply have the outer edge. This edge in this 2D sketch represents the same edge that's seen in this 2D sketch, just from a different viewpoint. This sketch is drawn on the X and Y axis plane, which is our front plane. This sketch is drawn on the X and Z axis plane, which is our top plane. The one thing these two planes have in common is our X axis, which means that this curve and this one have to be the same length in the X axis if we're going to properly combine them together. The sketch shown here also gives us additional information in the Z direction, which is not present in this sketch. And this sketch gives us information in the Y direction, which is not present in this sketch. Because what we are looking at are layout sketches, before we make the projection of these two curves, what we want to do is make copies of them so that we do not disturb our layout sketches. Otherwise our layout sketches will move to a different position in the feature tree, which we don't want to have happen. So on the front plane, I will make a new sketch. I'm just going to copy this element of the sketch using convert entities and then complete the sketch. I just want one line or curve in that sketch, and on my top plane I will do the same with this curve. Now what I'll do is hide my original layouts so I don't accidentally select them. So here's my outer edge when viewed from the front, the same outer edge viewed from the top. Both of them align with each other in the X direction. In other words, this point and this point are the same distance away from the origin in the X direction. Now, to combine these together, we're going to use a command which is not found on any of the toolbars. We're going to go to Insert, Curve, Projected. And the default is Sketch on Sketch. This will project one sketch onto the other and combine them together. So we'll grab this one, and we see highlighting is a new sketch. In fact, we see that it goes from the tip where both of them meet, and it goes up to the tail of the front sketch, and also when seen from above goes to the tail of the top sketch. The result now is that we no longer have two sketches lying on flat planes, but we have a single curve curving its way through three-dimensional space, and this curve is a blue line. It's not part of a sketch, it's not technically a 3D sketch, it's actually what we call a curve in Solidworks. You sometimes hear me use the term curve when I'm talking about a curve in a flat plane. That's just more of a generic term, but here we see in the feature tree we actually have a type of feature called a curve, which is different from the sketch elements that I was originally talking about. This curve then can be used as a guide for making the outer edge for a loft, which in this case is for our project 3. So combine this curve and this upper and lower curve, which in this case are sketches and are considered to be guide curves. We can draw profiles that have pierce relations to all three of these guide curves in order to finally create our loft. These two guide curves just lie in a flat plane, and this one lies in three-dimensional space. Here we see that this curve has managed the transition from one corner point to the next on each of these profiles. If we look at the final result, once again we get back to what we had desired in our layout. Here's our front layout being highlighted. Here's that curve seen from the front view. And here's the same shape shown from the top view, and I'll highlight my top layout. Here again we see that original top layout edge viewed from above. This has all been combined together into one three-dimensional object. This is a concept that a lot of people have trouble with, so maybe this will help. Here's a windy road, when seen from above. It's curving back and forth, and we see that it's gaining altitude at the same time. If we were to view this windy road on a map, we would just see it in a serpentine shape going back and forth without any sense for how the elevation goes up and down. If we saw the same windy road from the side, we would see how it makes elevation changes without being able to at all appreciate how it winds back and forth. Solidworks can allow us to combine two pieces of information, viewed from above and viewed from the side, in order to create the three-dimensional reality. I'm just going to delete the projected curve. And I'm going to turn on my sketches. These two sketches were copied from some layouts I made previously. From the top view, I have one sketch which represents how the road winds back and forth. This information is shown on the XZ plane, which is also known as the top plane. From the front view, I have the information on a completely separate sketch that shows how the elevation of the road changes as it progresses along. This information is contained on the YX plane, which of course is the front plane. Both sketches have the x-axis in common, meaning that both have to line up at their endpoints in the x direction. So both start at the right plane, progress over, and both make the same distance from the right plane to their endpoints. The goal then is to try to take these two pieces of information and pull them together to be one single road. Again, we'll go to Insert, Curve, Projected, Sketch on Sketch, and we'll select both curves, or rather both sketches, it's more precise. That combines them together into this single three-dimensional curve. If I turn on the original layouts, I can see from the front view which is obscuring my blue line just a little bit, I can see that the blue line matches up with the front view sketch. And I can see this very same blue line, when viewed from the top, is aligning with my top view sketch. So one way to look upon this is that the top view sketch is giving us the information of how the road is meandering back and forth in the X and Y directions. Actually, I mean X and Z directions, not the Y direction. In the front view, simply is adding the additional piece of missing information, which is how the road is changing its elevation in the Y-axis. An equally valid way of looking at it is that the front view is controlling how the road is moving about in the X and Y axis, and the top view is supplying the missing information as to how this is meandering back and forth in the Z axis.